What does it mean to factor? Okay? What it means to factor is to break down something into a product. Okay? So this means to break down into a product. Alright? Factoring is to break down something into a product. Either a monomial, binomial, trinomial, or any polynomial. Okay? Now from the past, I'll put an example of 12 up here. 12 is a monomial. It has no variables. It's just this constant term of 12. But it is considered to be a monomial. It's a single term. Okay? Going back to your old multiplication tables, you know that 12 breaks up into 3 times 4. This is a product. Okay? This product multiplied together, which means that each one of these is called a factor of 12. We would say 3 is a factor of 12. We would also say 4 is a factor of 12. Okay? Easy example there. Let's do another one with some variables in it. What if we were to say something like 60x squared? Okay? That looks like a monomial that we're used to for this particular unit. With the coefficient of 60 and the variable of x squared, okay, power of 2. We can break this one down. I mean, again, you don't have to break it down to its prime factorization, but you can just break it down into a product. Okay? Let's say 6 times 10 times x times x. We can break it down even further. But again, breaking down into a product is what factoring is all about. Each one of these is a factor of 60x squared. So these are factors of the monomial. Each one of these. So, we want to break things down to multiply. Okay? Pretty soon we're going to take a trinomial and we're going to break it down into a product of 2 binomials. We're going to work backwards. Remember when we did the full method where we did the first, the outer, the inner, and the last, and we got the trinomial as the answer? Well, we're going to go backwards from that and go from the trinomial back to the 2 binomials. Okay? We've got to work our way up to it first. The first key of factoring, the first thing that you have to accomplish is you have to master the idea of GCF. Okay. Does anyone know what GCF stands for?
Greatest common factor.
Greatest common factor. That's exactly what it stands for. So, it is a rule. Now, the GCFs that you've done before now have been with numbers. Okay? For instance, let's go back to just 2 numerical examples here. Let's say, what is the GCF for, let's say, 12 and 8? Okay? Meaning, what is the largest number that goes into both 12 and 8 evenly? That is a factor of both of them. Anybody got the answer?
4.
Say it. 4. Everybody agree it's 4? Okay. 2 goes into both of them, yes. 4 goes into both of them, yes. Does anything higher than 4 go into both of them? No. So we would say that the answer is 4 is the GCF. It is the largest common factor. That's what GCF stands for. So we've done GCF for quite some time. Now we're going to start throwing in some variables. We're going to start talking about monomials and trinomials and all that good stuff. But the idea is still the same. Okay? Everybody got this example down? Very easy. So I always like to start with an idea that, hey, you've been doing this before. Now let's apply it to the new stuff. The new stuff is going to be something like this. What is the GCF of these 2 monomials? Let's say we have 65x to the fourth, and we have 42x squared. Okay. Now, we have to look at them into two parts. The coefficient portion and the variable portion. Okay. The variable portion is very easy to determine. So I'll start with that one first. The variable portion, we have x to the fourth, we have x squared. What's the largest amount of x's that both of them have? 2. Everybody agree with that? So the GCF portion that's the variable portion would be x squared. Okay, so we know it's something x squared. Everybody agree with that? Okay. Now, we look at the numerical portion. 65 and 42. If you can't see it automatically, what you may want to do is you may want to do the prime factorization of each and circle matches. Okay? So I'll come over here to the side and I'll put 65. That breaks up into 5 times what? 13. And guess what? Both of those are prime, right? Alright, 42. 2 times 21. 3 times 7. And that's all prime as well. Do we have any matches? We don't have any matches, do we? So, no matches. What goes in the blank is actually a 1. 1 is a factor of everything, correct? Yeah. Now, in the book or on the test or somewhere, are you going to see 1x squared? What will you probably see? Just x squared. That's the simplified version of it. It's an understood 1 coefficient. X squared is the GCF. Okay? Let's do another one, then we'll make some rules up. I'm all about rules. You know what? All my graphic organizers, I like to say, do this, do this, do this, right? Checklist. Hey, check these things, right? Do these steps. 1, 2, 3. A, B, C. I like to give you those just so you have something to go by. So, let's do another one of these, and I'll give you a second for you to kind of work it down on your paper. So let's find the GCF of this one. Let's go 404 x squared y to the third. Is it going to mess you up if you have 2 variables? No, you just take each variable independently, put them together. So find the GCF between 404 x squared y to the third and 62 x y squared. That's an ugly pen. Is 1 prime?
Yes.
I think it is. So the prime factorization is not really that bad. 31's prime as well. Doesn't take long.
Yeah.
Say that again? It is 2. 2 is a common factor here, and that's all we have in common. So guess what? 2 is the greatest common factor of the coefficients. It's not that hard. Okay? Then we look at the x's, and then we look at the y's. We have x to the second, x to the first. How many x's do we need? 1. So we say x. Then we look at the y's, y to the third, y to the second. How many y's?
2.
How many? 2. So it'll be y squared. 2xy squared is the GCF.
Why would it be y squared?
Because this one has y squared, this one has y to the third, so they have 2 y's in common. If you break down y cubed into the prime factorization, it's easy to do. It's just y, right?
Okay.
And then y squared has y and y. So circle matches. Multiply them together, you get y squared. Okay? Ask questions. There's no such thing as a dumb question. Okay? No such thing. Yes, sir?
And what do you do for x squared?
Alright, x squared. Same thing here. The idea is that if we break them down into the prime factorization, break them down into their parts, this is x squared, which is just x and x. That one's just x, which is just x. Circle matches. Put the match here. No dumb question. Any more? Alright. Progressively getting larger and larger with the problem here, and I'm going to start throwing in more variables. All right, here's a super duper hard one. Ready? Let's go with 18, x to the third, y to the fourth, z to the fifth, a to the sixth, b to the seventh. Yeah, I like that. And underneath it we'll put 6xz squared, a to the 8th, b to the 11th. All right, remember guys, the greatest common factor has to be common between both of the terms. Here's the problem. This one has a y, this one does not. So is y going to be a common factor for both things?
No.
The answer is no. It's like saying, what's common about two people in this room? Okay, if I just pick two people at random, for instance, this is a good example. Caleb and Kittle are right here in front of me. Okay, what do they have in common? First of all,
They're white. Same color hair.
they're white. It's a commonality.
Same color hair.
Same color hair. Okay, same gender. Okay, but do they have on the same shirt? So is shirt a commonality between those two? It's not it's not one of the factors that's the same. Okay? One has on long sleeves, one has on short sleeves. One has on shorts. No, they both have on shorts. Okay. Do you understand the difference though? Because they have on different colored shirts, we can't call that a common factor between those two. Okay. If I were to pick a boy and a girl, the biggest difference is that the gender is different. So here, this is like saying black shirt, no black shirt. So if he does have a black shirt on, I can't say that's something in common, right? Yeah? Yes, yes? Good to go. All right, so what is the GCF? Let's start with the numerical portion. The numerical portion is 18 and 6. Okay, it's got to be 6. A lot of people will put 3. You're thinking small. Keep going. 6 does go into 6 one time. It is a factor. 6 goes into 18. Remember, if you break down 18, that's 3 times 6, and that's 2 times 3. Okay, so here's your factors. If you break down 6, that's 2 times 3. Circle your matches. Multiply them together, it gives you 6. Okay. So if you didn't see this right off the bat, break it down into the prime factorization, circle your pairs, and multiply your pairs together to get the greatest common factor. Okay. Now we look at each individual variable separately. Do they have x's in common? Yes or no?
Yes.
How many? 1. So we just put x. Do they have y's in common? No, so we don't write it down. Do they have z's in common?
Yes.
How many? 2. Do they have a's in common?
Yes.
How many?
6.
6. This one has 6, this one has 8, so they at least have 6 for each one. All right, b's in common? Yes, they have b's in common. How many b's? 7. Answer, GCF. GCF is 6x z squared, a to the 6th, b to the 7th. All right, so what are we doing? On a test, on a quiz, on the EOCT, they may ask you, give you 2 terms and say, what's the GCF? Real easy, it's what we've been doing. Or they may say factor by using the GCF. Okay, what does that mean?